Hi, it's Andre again. Today we're talking all about keyboards, and I'm not talking about the original ones. I'm talking about new ones for the Commodore PET and my UltiPET, so stay tuned. If you look at the Commodore PET keyboards, you can see those are rather dumb ones. This is not an original, this is a normal rebuild. And well, the Commodore just scans the keyboard like on the Commodore 64, 8 keys at a time, then checks if each one of those keys is pressed and sends that into the keyboard buffer. So that's just a matrix of switches between 8 input and 10 input lines and 8 output lines. And it has this single line connector, which is common to all the pads. And however, this is tedious to build. So when I built my UltiPET, I was wondering, can we do better than that? And one thing I did is I created a new interface, which is now using IDC cables and has some more features. Also, I added, like on this one, I added 2 controllers. This one and well, this one. Yeah, those 2 Atmega controllers. One for LED backlighting. Yeah, you can see those are a lot of LEDs. And one for keyboard mapping. And we're going to have a look at what you can do with them in a moment. Also, as you can see here, I already had those keycaps and I printed them in a transparent way. But I also added some new features because the controller can now remap the keys. I changed the keys here. You can see that, and I'm going to talk about that in a moment as well. What's so special about those keys? So if you follow me along, I'm going to talk about the new interface, which leaves opens a lot of opportunities, what you can do with the keyboard. You're going to look at the light effects. We're going to look at the keyboard mapping and how you can actually use it in BASIC. And if you follow me along at the end, you can actually see how I actually built the whole keyboard. I will also tell a story about parts provider not adhering to their own datasheet. So, well, stay with me and we're going to look at the new interface first. Now I want to talk about the new keyboard interface that I did. If you look at one of the older keyboards that I have, you can see the original PET keyboard connector, which is basically something like this. It's a 2.54 millimeter pitch. Yeah, it's not a flat ribbon cable. And I think this one has a broken connection, but maybe a barely connected anyway. Yeah, they are tedious to actually build and they're taking up actually more space than I wanted. And they don't have power. So I decided I'm going to do something else. So what are the features of the new connector? This new connector is using IDC cables, which are easy to produce, available everywhere, and no soldering required. Instead of, the original connector had 10 row select lines going to the keyboard, into the keyboard, and 8 sense lines going back to the pad, like similar to the Commodore 64, where you have 8 select lines going into the keyboard and 8 lines going out to build your keyboard matrix. This has 10, and on the PCB there actually is, and it's not here anymore, 4-bit to 10-bit decoder that actually takes 4 bits from the I/O chip and decodes it into the 10 bits that are going onto that old connector. So I decided I remove that one basically from the motherboard or make it optional, and just sent the 4 lines over here. What I also did is I added 3.3 volt power, I added 5 volt power, and I added reset, an interrupt, and I2C. So basically you have a full I2C capable bus here. You can basically do connect anything you want, and bummer. And so what I did is I created those keyboards that have Atmegas on them to do some work, and for LED and decoding, and basically I don't want to miss that connector anymore. Everything else, every future version will have the old connector on the PCB, but and the keyboard that I did here is, as you can see, you still have the option to use the old connector, but I'm not ever going to use it again. And you can see here there are 2 Atmega controllers that speak I2C, and yeah, you can use the board, the PCB, like a normal PET keyboard. You just have to solder some of the jumpers around here, so it's all in the documentation. You can basically then you basically have an original PET keyboard, but no extra features. But I really want to have those extra features, and that's why I created this new keyboard connector. So what else is there? As I have shown, there is this new keyboard connector, and it not only has the keyboard connections to scan the keyboard, but also I2C, as well as power, reset. So you can actually, and it's the reset button, more or less. You can press shift lock 3 seconds, and by the way, shift lock works. Also a feature. Shift lock key a few seconds, so it resets the machine. And yeah, and you can see here nice effects on the keyboard. Colors over. You can come on. This little demo, which really only has some basic, some print line, there's an open, and some data which shows the rows. And the reason for that is, in BASIC, you can actually send commands to the I2C bus. There's some more integration which is more experimental, but you can actually control the LEDs of the keyboard with BASIC. Ta-da! How you like that? So here's the new keyboard. Now let's see what we can do with it. You see the upper key rows have not just the symbols like the exclamation mark, quote, hash, dollar, percentage, and so on. They also have the numbers. Those are not on the original keyboard. The original keyboard only has the symbols here, and that irritates many people when they try to use the PET. So how can you do that? You press the system request key for a couple of seconds, and then you can see the keyboard talks to you, and it tells you press 1 to enable upper row digits or 0 to disable. So 0 disable, So those are just the digits. Now do that again. Press 1. Digits enabled. And then you can see here, you have the digits. And with Shift, you get, you get the symbols. And how do you get the graphic sign on the front? Use the new control key. So that's a very cool feature of that keyboard, and that can be extended. For example, I think about switching Z and Y for our German users. Another cool thing that I'm playing around with is, and you may have seen it already, is this little analog joystick thing. So you can actually have multiple keyboards connected at the same time. They basically both work, and you can see the information which key is pressed is going over I2C. So the LED controller on this board receives the I2C information from the other board as well and lights up. So it's connected to the same bus. And now what is really missing on this board is an inverse T-shaped cursor keys or a cursor cross or something. You could potentially map the number pad to cursor keys. So that may be one idea that you can do with some settings in the keyboard. But this analog joystick is, I'm still looking for some good place to put, because that can also drive the cursor. If you look at this keyboard here, and I'm using this analog joystick, and you can see I'm actually controlling it with the mouse, with the joystick. There's only one thing. So currently the keyboard scan matrix can only use one direction and shift the direction. So if I press both, that wouldn't work because I could use not all diagonals. If one of the cursor keys would be shifted and the other would not. So unfortunately, right now, this is only in straight lines and not diagonals or anything like that. But that may change. So that's something I'm experimenting with. So let me know what you like more, if you would like to find the solution where I'm using the keypad as cursors, or if you have any other idea how to place those keys somewhere, let me know in the comments below. So let's talk about the LED problems that I encountered. When you look at the board, you can see there are all those backlighting LEDs, and they have to be put into the board with a certain orientation. Now this one is an earlier version that I did, and I had no problem. I was using the orientation specified in the datasheet that I had. But then the new ones that I built came in with the LEDs 180 degrees turned, and the pin 1 indicator was just on the other edge of the part. And it turned out that the provider, the manufacturer of the LEDs, had changed the datasheet, which is a real bummer. So I'm going to show you the datasheet and then how to hopefully avoid that problem in the future. And in the later section, you can actually see how I had to resolder SMD rework all those LEDs. So to understand why this happens, let's look at the datasheet. You can see here SK6812 Mini E, which is the LED, and this is the datasheet from Adafruit. And if you go down here and look at the pinout, you can actually see that this little cut edge is ground, but it's pin 3, which is yeah, okay, that's how I designed the board originally. But if you go to JLZ PCB and look at the datasheet here, yeah, you can see that the little cut edge ground is pin 1. So please make sure if you go to your board house to make sure they have the right orientation. So this is the keyboard PCB in Keycap, and you can see that's the top view. The number pad is on the right, the connector is on the top, and now let's switch to the bottom view. So you see the number pad is on the left, the connector is to the right, so that was the orientation I just showed on the real board. Now you have to make sure that these LEDs are installed in the right direction, and that's why I have added this here on the silk screen. So hopefully that will not happen again. So for example, you can see here that ground is on the bottom left, and we have VCC on the top right. And that's how it should be in the datasheet. Building a keyboard not only includes the board, the PCB and the switches, but also the keycaps, which are the one thing that you actually see in most of a keyboard. And I had already prepared 3D printed designs that I had printed by a provider nicely, like here in white, or as you've seen in transparent already. And I wanted to have them printed in black now. However, I ran into a very strange problem with the same provider I got them from, and that's the next section. Okay, so let's look at the keys that we have here, and they actually look quite nice. Very nicely printed. You barely see any lines, if at all. So those are very nice. So I got them from PCB Way, like the other prints I just showed. But then suddenly, when I submitted them in 5 parts because I had download problems on Tinkercad where I did the designs. One of those went through like the previous prints for about the same price. And then I got some very strange discussion with the customer service, and I said, okay, there's many small parts that need to be handled separately, and that costs extra fees and yada yada yada, and I had to pay almost twice as much, and also I had additional customs, and that was really very strange behavior. Maybe let me know in the comments down below if that is your experience, or what experience you have in such situation, because as I've shown, this is the third one I printed, and the other 2 just went through with very reasonable pricing. Then I also submitted the one to JLZ PCB, and they said, okay, we can't do these things separate, or at least that's they pointed me to a website, help support site, where they say, okay, you have to put them together like such. So yeah, the print quality is, I think, comparable, and yeah, you get them separately here with a high price, or you get them to a reasonable price here, but you have to cut them off, and then you have those little, yeah, you have to make sure you cut them very cleanly, and then maybe have some, yeah, break them off here like that. You see that you have to take care of that to clean that up, which is extra work you have to do. Thanks for following me until this point, and I've made the main points of the video in the sections you've already seen. So I'll leave you here at this point. Hope you enjoyed it. And if you want, you can still watch the rest of the video, which is basically a lot of recordings that I did actually building the keyboard, means SMD rework of the LEDs that I mentioned, coloring the keycaps, putting some coat on them with clear coating with the airbrush, and putting it all together, building the frame actually. So yeah, you can watch that if you like. Otherwise, thanks for watching and see you next time. This is the keyboard PCB as I got it. This is the side from the top, and there is basically nothing on there because everything is on the bottom. And you can see here two Atmega controllers, some logic, a lot of LEDs, capacitors. Yeah, the only problem is the provider of those little tiny LEDs that actually shine through the PCB through these holes have changed the datasheet. They have changed the pinout. So I got them in turned 180 degrees, so I have to rework them now. And I'm going to use a hot air gun for this. And I'm going to use some protection here because on the first one I did, you can see here, I actually burned my desk. But anyway, let's get started. I can actually smell I can actually smell the hot wood, the burned wood. So here is the keyboard PCB and void of all the LEDs. Touch it with tweezers only. It's really still emanating heat, so it's really gotten hot. The heat was over 350 degrees Celsius, and as you can see here again, the wood got burned. So it's very good to have that protection underneath. And if you're doing that at home, please use something that's flame resistant or doesn't burn very well. The board has cooled down, so I can actually touch it. And now I'm applying, where's the camera? There's the camera. Now I'm applying flux. So I can just place the LEDs then and use the hot air gun again to resolder them. Okay, all LEDs got some flux, and now it's time to get those in. So I have placed all the LEDs back where they should belong now in the correct orientation, and yeah, we can verify like so if all of them have their little dark dot on the right, on the correct spot. But anyway, we'll see. We'll see about that when it doesn't work. But it looks good so far. There is no need to actually put them really 100% into place, because due to the flux and then the soldering, the hot air soldering, they will just pop into the correct place when the solder is really is flowing again due to the heat. And that's what's coming up next. Okay, here we have the soldered PCB, and I think all LEDs should have worked, maybe except for this one, which I'm going to check later. So the first thing is it's hot, and I burned some more of the wood, so I only touch it with tweezers. But next step will be functional test and then soldering all the switches. Now, to get this board PCB in a working state, after that we first need to clean the flux off. So that's just normal isopropanol, basically. There's probably better ways to do that, but yeah, that's what I'm doing. Then let's cut off those parts that are actually not part of the PCB, but part of the production process, coming from the production process. Next thing is to add the connection and programming headers. This one goes here like this. It goes basically to the underside of the PCB. This is the first thing here. That's where the new connection is. You can see you can also use the old connection, but with limited functionality, basically without more or less the controllers. So, but here are the programming connections, and they go on the top. They go here. So. And while I'm at it, I'm going to fix that one LED that might not have been soldered correctly with the air gun. So, on to testing. So what I've set up here is I have here the Ultipat, I have the new keyboard cable, and I've also connected this one to the new keyboard cable, and you can basically see here there's some light effects here. So, and here is the programmer for the Atmega, and now I'm going to program that Atmega, make fuses, make flash, and then you can basically already type on it. Because there are no keys, you have to trigger the keys differently. So that's what I'm gonna do here. Basically, oops, can you see that? If I'm trying to do that here, okay, this one is not working for whatever reason. I just had it here. Okay, well, maybe have a look later. That's very strange because you can see it here. If I maybe there was no contact. So if I touch the key here with tweezers, basically simulating the key touch, you can already see the light effect on the existing keyboard. And the reason for that is because this new cable has an I2C bus, and the two Atmegas here, they are actually talking to each other with the I2C bus. And because the two Atmegas in that keyboard are on the same I2C bus, of course, if the keyboard controller on this board sends a signal, okay, this key has been pressed, this one receives it as well and gets the LED effect. But it's not working the other way around yet, because I need to program the LED controller. Sorry. I need to put in the programming cable. And then I need to go into the LED controller folder, make fuses, make flash. So now you can see when I press the keys on this keyboard, the LEDs on this one are working as well. Maybe as you can see, maybe I have to check if every LED is working. I'm not convinced. I think there are some missing around here because of the whole soldering thing. So, but yeah, I call that a success for now. So by pressing the right keys, I identified that there are this key here, basically the left arrow, and the keys here, which is the percentage and the apostrophe and the T and the Y are not working. All other LEDs are working. Those four are, when you look at the schematic, they are basically in a chain together. And the input or the upstream signal is coming from switch 46. This goes to switch 54, which is the first one that's not working. So it may be here or here. Maybe the output signal is not coming through, and here maybe the input signal is not coming through. And then there here, the signal for switch 75 is coming from switch 59. So I need to check those four pins, keys. So resoldering just one or two connections, and then you can see all of the LEDs are now working. So the next task is to actually put on and solder the actual keys. Note I'm using the ones with the pins that align them properly, so you don't have, so it's all on the PCB. You don't have to have any external way of stabilizing or aligning the actual key. And those are the clear ones. You can use any other, but if you use others, you will not have the benefit of the LEDs. I think. I never tried it. Okay. These are installed. On to the soldering. Now it's about soldering all those pins in. So, does not seem I have forgotten anything. So let's put some color on those keys. So that's a little IPA, so we're using alcohol ink, like this one. And that's the first time I'm using this one, so let me see how it goes. It's probably too much already. But let's see. Taking a syringe with very, very fine, that's the finest I could find it. Probably there are better ones, but oh yeah. Okay. Now let's take that syringe and slightly push the color into the engraving on the key. Oops. And of course I already spilled it over. Could also put that on the front. But that's all not a problem because we're using alcoholic ink. So we're gonna fix that later with the IPA. And now it's just grunt work going through all the keys. Front and top. So I'm cleaning the syringe now, putting in IPA. Just a little bit. So it doesn't clog the actual syringe, so I can reuse it. Okay. And there you have it. All keys with color, although certainly spilled. So I have to clean them up with IPA from the top and from the side, but not inside the engravings, inside the grooves. And then, yeah, that's the next step. Now let's have a look. Let's have a go at cleaning up the keys. As you can see here, I spilled over, and now I need to clean that up. So only really the letter and the writing is visible and has that is white in color. So I'm trying that with those first time. So let's see if how that works out. Well, that actually looks good. Oh, wait, what? No. Okay. Oh, look at this. Is it taking off material? So I'll probably wait some more because I think not all of the ink is fully dried yet. So I'll do that off camera and show you the results then later. So what we're now doing is putting on the first clear coat onto the keycaps. I'm using satin varnish. Well, let's see how it goes. It's the first time I do this, so except for some test keys, so we'll see. And now it has to dry a day, and then we'll get the second coat, and then we'll try it on the keyboard. So let's install the keycaps onto the keyboard, and I'm using this one as a reference. So I know this is 0 and so on. What you can see here is something that I'm going to talk about in a moment, because the original PET only has the symbols on the top row, but this keyboard can have both. Tja, der ist wohl runtergefallen. So, a couple of observations. Maybe I'm not sure if you see it on camera, but I used two different filaments, basically rests of some other spools, because that's inside and I don't care how it looks. Breaking that off actually wasn't planned. It seems that's just the border between the two filaments. You can see here those, I don't know, yeah, those carvings here. So you can actually use that if you shorten it in the design. Don't short that when it's printed already. In an actual PET, and those parts that oh look, there's missing. The screw posts are wider than expected, and so I had to carve out some places here. Also, you can use that in a Commodore 64, and as you can see here, those are things where I'm not exactly the same dimension as the one from the 64 or the original. But with these you can actually use it in the plexi laser case once I figure out the dimensions for the plexi laser stuff. To glue it together, this time it's the first time I'm using actual super glue, or Sekundenkleber in German. I used to have it with, say like this, with hot glue, but this tends to fall apart at some point. So that's the first time I'm really trying it with super glue. And what I learned is using an activator should help a lot. So that's what needs to be done. And then what I did here, I'm using these carvings and parts that overlap. So I have some area that helps in sticking together. It's not just the front side of the part. So well, let's see how it works out. I'm using the knot. Okay. Ah. I'm using super glue that's not totally liquid. So let's see how it works. And I'll press it together. And wear gloves. And it's set to put some more activator on top of it. Let's see how it works out. So this is the keyboard now, and as you can see, I've added the missing key now. And here is the frame. And how do you install it? Basically, you slide it into those little holders here, brackets, whatever, and then snap it in on the top side. So the only point is where you need to understand where to put it. And for a Commodore 64 case and for the UltiPET case, there are two different settings. You can see, maybe you can see these little holes where at what used to be where the screws were supposed to be. The left one is for the C64, the right one is for the UltiPET. And about you need to put it here in, and then you just push it in like so. And there you go. There's your new UltiPET keyboard. I think I put it in the wrong spot. Yes, of course. Because and that's always the same thing, and I need to find a solution for that. So just give me a sec. You can see how, where is it? How this hole needs to align with actually the right one here, and it's not. So I'm using the really and now I went too far with it, of course. Ah. So that should basically be it, maybe a little millimeter more on this side. First too far again. So now it's perfect. And there you have it, a new UltiPET keyboard.